Good morning. Thanks for coming to my talk on CQRS, Akka and Scala Type System. Before we start, I'd like to ask one thing. We have 3 hour slots with a break of 30 minutes, but I was wondering, do you guys prefer to have two breaks of 50 minutes, or is it too much to stay here for 1 hour and a quarter, or do you prefer two breaks? No opinion? Two breaks? Yeah? Okay, so we do, I'll not say that we do 50 minutes each time. Let's see when I reach a point that I think it's okay to make a break around 50 minutes, then we break for 50 minutes and then we come back. Okay, so first a little bit about me. My name is Renato Cavalcanti and I'm independent consultant. I live here in Belgium. I do mainly Scala. I'm founder of the Belgian Scala user group. And you can reach me on this, my Twitter, my email address. I have a company called Strong Typed, where we give consultants, Scala consultants and training. And codes that I write you can find whether on my own GitHub repo or on the Strong Typed repo. So first, some credits to people that helped me learn everything that I present here. I work for the Flemish government in the Agentschap Wegen en Verkeer, which is the agency that takes care of the roads in Flanders. And those names here, the first on top, these are my team. All those people, well, there are two persons here. Caro Mazen is the main architect over all the teams, and Peter Mortier. Those two are not my direct colleagues, but they all participate on our adventure into CQRS. Actually, Peter was the first one that implemented something inside AWV, Agentschap Wegen en Verkeer, where we were using CQRS, and from there we built other systems. And what we see here is what I learned, what we learn, things that we have brainstormed together. And well, at some point I said, okay, if I had to start from scratch again, how will you do that? Because of course you build your first CQRS application, you make some mistakes, you learn some things. And we have now, I think, 4 CQRS applications running. They are all a little bit different. We apply different approaches. But what we have here is what I believe up to now, of course, how we should do it. The code, I made it open source because it's, well, part of it comes from there, but also lots of my own free time I put here. And I have one open source committer, Dan Broek. I gave that talk at Mr. Don Scala User Group, and that guy came and make a fork of the system of the code and did some improvements, and so he's also contributing now. So the agenda for today, well, you see, we have lots of content, and as I said, I did that talk not only on the Scala user group in Amsterdam, but also other user groups and the Scala conference, and I realized that there are a lot of content, and it's very deep at the end. So this is what I will try to cover today. I have some extra things that if we have time I will show. But mainly what I will try to show is, well, that I try to explain is what is CQRS, actually basically, what is that all about, how I do that using Akka, and why Akka is interesting for us. So why asynchronous programming is a good fit for CQRS applications. How I can use Akka Persistence to implement event sourcing, and Akka Persistence query to build projections. But of course, we also have a look on how to code that all using Scala and some things you can do to make it a little bit more robust. So DDD, CQRS, and event source. We hear a lot about that, and most people think it's all the same thing, but it's not. So there are 3 separate concepts, and of course, when you build a CQRS application, usually you use concept from these 3. It's not a pattern, but like say techniques. So in DDD, there are many concepts, but the most important concept for us is the concept of an aggregate. And what is an aggregate? The idea of an aggregate is that you have a graph of objects where there is one object that's the main object, okay? And all the operations that we'll do from that main object that we call the aggregate root. So for instance, if you have an order, you make an order for a customer and you add products to it. So all the operations are on the order level. You initialize the order and you for a given customer and you start to make operations on it. You add products, you remove products, and you execute the order or you cancel it. So that's the one example of an aggregate root. Of course, you not always need to have a complex graph of objects. You can have only one object that is in itself an aggregate and an aggregate root. It does not need to be a tree of objects. And that aggregate root is responsible for the consistency of the whole, okay? And it could only modify one aggregate per transaction, and that's sometimes difficult to grab because you can imagine that in some situations you want to change one aggregate together with another one, or you change one aggregate and it should impact the other one, and you try to make them that all happen on the same transaction. Well, if you're doing that, it's probably because you have the wrong aggregate. So it's really important in DDD that you only change one aggregate per transaction. And the idea, the reason for that is that the aggregate represents the consistency boundary of your business problem. So if you are trying to build a transaction over more than one aggregate, then the consistency boundary of your business model is not well defined. So moving to CQRS, well, CQRS, which means command query responsibility segregation, it's a term coined by Greg Young that he based himself on another concept, which is CQS, command query segregation, and which was a term invented by Bertrand Meyer. And Bertrand Meyer had his idea was a well-defined object has method that only execute things, that accept commands, and methods that returns data, that returns results of queries. And if you think about Java bean setters and getters, that's exactly what it is. And you don't have a setter that change things and return a value at the same time. And but Greg Young pushed it a little bit further and said, okay, and if you have two different objects, one that only accepts commands and only that where we can query. So the idea of CQRS is to really split those two. And he has this definition where he says it's simply the creation of two objects where there was previously only one, which is of course a very minimal explanation, but on its core, that's what it is. So at one side, you have this write model that will accept commands. And it will produce events. And the event is very important here because the event is what we'll use to communicate with the write model or to the read model. So commands are produced on the write model, are sent to the write model, events are produced, and the events are used to create your read model. So basically, everything in your application is about events, what happened in your application. And of course, you can store the events, and when you store it, you can replay it, you can make audits. And you have many reasons to build a CQRS application. One of them is performance. You need to process commands in a very performant way. The other reason is when you need auditing. At the Flemish government, you can imagine that we don't have 100,000 users using our applications. We are doing that mainly because of auditing, and also because we see that it's very efficient if we can replay our events. If you have an error, we can fix the system and replay the events, and we fix the system by doing that. We don't do much migration, actually. So what is event-driven? So CQRS is what is event sourcing? Sorry. CQRS is event-driven, but it's not necessarily event sourcing. Does not necessarily implement event sourcing. What it does mean, if you think about, okay, I have the write model and the read model, I need to communicate, the communication between the two sides are through this event. So that's why it's event-driven. But it's only implements event sourcing when you start to save the events. And then you have a source of events in your system. So let's see, if you build a synchronous CQRS, how it looks like. So imagine that you have a transaction of a process somehow, and it starts with a command that you apply to a write model that produces an event, and you generate a view from that. The view is our read model, okay? So this all happens in one transaction. If the generation of the view fails, then you roll back everything. That's basically what we do in a classical Java application, where we actually have only one model, and we use it to execute commands and as view of our model as well. And if I need more than one view, for instance, I need reporting, I need a view for my web app, I need a view for my browser, and so on. So if I have more than one view, I have to generate all those views or update all those views on the same transaction. And if one of them fails, then I have to roll back everything. And of course, this won't scale. No? It becomes very annoying to write all those views when I receive a request come from the user. So the idea of CQRS is to avoid that by making it asynchronous. So you have your main transaction where you receive a command, you modify the write model, and you save the event. And that's one transaction. That is strict consistent. Then that event will be used to generate your views. But of course, you introduce event consistency. Why? Because, well, I send a command to my write model. Let's say that command is a valid one. It will modify my write model, and then on the screen will not be updated yet, because my view will only be updated a little bit later. So when you do that, you choose for event consistent by definition. One possible thing that you can do is to say, okay, I have my main view, and my main view is on the same transaction as my write model. The view for my GUI, I just decide to update or create that at the same transaction. All the other views I do asynchronous. That's one of the possibilities. But I will not see that option today. It's a little bit more complex, actually. So, just to recap what we saw, Aggregate is responsible for the consistency, and it's a DDD concept. Okay, you can only modify one aggregate per transaction. It's also a DDD rule, actually. You have write models that receive commands and produce events. That's pure CQRS. That's not DDD. You have strict consistency on the write model. What it means, actually, the aggregate, which is a DDD concept, in a CQRS application, when you mix them, the aggregate is your write model. So your write model validates your commands, and the write model produces the events. That's where everything starts. Everything starts from there. So the write model is your aggregate and is strict consistent. Then, when you start to generate your events to produce a read model, that's pure CQRS. And when you persist your events, then you're doing event sourcing. But also, you're going asynchronous, in asynchronous mode, and you're introducing event consistency in your system. Okay? And, well, as I said, yeah, you can store and replay the events. So if you think about the basic operation that we can have in such a system, we can start with some code. It's not the real code that I will use, but just to give an introduction of the main concepts. Let's say that I have a trait, which in Scala is an interface, is the equivalent of an interface in Java, Java an interface, and I have a command, an event, and an aggregate, okay? And I have something that I will call a behavior. And the behavior starts with a method that validates the first command. At the beginning, you don't have an aggregate, you have nothing, you need to construct it. So think about that validate method as the part of your constructor. It's not yet your constructor, but the method that validates the input parameters of your constructor, okay? So if I have a valid command, let's say I'm creating a product and I need a name, a description, and a price. And if the price is below 0, it's probably a wrong command. It's not a valid command. I will not create a product that costs less than 0. So that's one example. So that method should only produce an event if the command is valid, okay? But it produces an event, but I still don't have an aggregate. That event I use to produce an aggregate. So once I have my first event, I apply it to nothing actually, because I don't have an aggregate, but I produce an aggregate from it. And then actually those two methods here are my constructor. And the first question is why I have two methods. I have two methods for two reasons. First is that I want to write code in between. I want to have this behavior with two separated methods where I can first validate, and if I have an event, I can save it, and after saving, I can generate my aggregate. And the other reason is that when I replay my events, imagine that you want to replay your events from scratch. You don't save the commands, you only save the events. So I need that when I'm replaying my events, I only call that method. So I need a method that accepts events and produce aggregates. Okay? But once I have an aggregate, I want to update it. So the next method that we have is how I validate a command against an existing instance of an aggregate. And so the second validate method receives a command and an aggregate, check if that command is valid for this given instance of this aggregate, and it will produce an event. And again, I have the apply event for an existing aggregate, which will basically modify that aggregate with that event. You apply that event on the aggregate, and you produce a new instance of this aggregate. Of course, in Scala, we use immutable data structures, and my aggregate will be a case class. So what I want is to have an aggregate, and I will produce another one. I will not do setters on that object. So these are the basic operations that a CQRS application has to implement, I think, more or less. We'll revisit this behavior in a while. And by the way, this is a non-reactive one, which is not the right one for us. We'll see how we'll change that. But the main operations are, I have two validate methods and two apply methods. The first validate and the first apply method is when I'm constructing my object, and the second validate and the second apply method is to update my aggregate. So how it works actually, I have some animations to show how it visually how it works exactly. So I get my first command. I have nothing, and I validate it, and I produce my first domain event. So in our example, I have a lottery application, and my first command is create lottery that will produce the event lottery created. And it's always like that. You have a command that are in an imperative term, create lottery, and you have the events that are in the past tense. Okay? Once I have a lottery created, I will apply it and create my aggregate. So here below we see, I cannot use the pointer, so here below I see my first event on my event store, and once I apply it, I will create my first state, the first state of my aggregate, just a fresh lottery object, aggregate object. Then there is another command coming in, that's add participant, that I apply on the lottery object, on the lottery aggregate, and it produces a new event, participant added, and so on. And I apply that event, and I produce a new lottery instance, which is the state 2 here. And there we go. I run the lottery. That will select a winner. I have the winner selected event that I apply, and then I have it. But what happens if I receive again the same command to run that lottery? I just select a winner. So in that case, I should not produce an event. I cannot select another winner because I have one already. So actually, this operation is invalid. So this command should be refused. And that order that you see here is a mistake. Because it was, my previous example was an order, but I realized I decided to change the lottery, and I forgot to change this one. Sorry for that. So the lottery is already executed or run, so I cannot run it again. So, but as you see, this API does not help me to handle this case. You may think that we'll throw an exception here, but that's not what we do in Scala. So we'll change our API to not throw exception. But what I want to say is that that command, it's a valid one. And I should not accept it, and I should not produce a new event from that. So my flow of events stops in event 3. Event 4 will never happen, okay? And if my application crashes, or if I stop it, I have to bring my aggregate back to state. And at that time, I don't have the comments anymore. The comments, they are discardable. You can save it, but it's not the main goal. It's not necessary. So if I start my application again, I just read from my event stream, from my event store, and I start to, here I will only use the apply event commands. And I reapply the events. So the first one was create lottery created, actually, in the past tense, and then participant added, and then winner selected. And then I have my aggregate back to the state when my application stopped because of a crash or whatever, okay? So basically, the idea of having event sourcing is that you can read only the events back again and replay your aggregate. So, of course, I need some infrastructure to save my events, to receive the commands, to apply, to hold an instance of an aggregate in memory, and we use Akka for that. And I put here the signature of the receive partial function, which is the main function that we implement in Akka. And basically the idea, what I want to show with that signature is that Akka, it's very powerful. It's all about a partial function that goes from any to unit, which any is the equivalent of an object in Java object in the Scala type system, and unit is the equivalent of void. So actually it can receive any message, and it will always transform it to units. It will consume any message, actually. Of course, this is very, very powerful, but also very hard to work with. Well, very hard. It's not hard, but it's something that you have to think about. And Akka, it's useful to build different kind of systems, but if you have a system that you know exactly what will happen in your system, that signature is too broad. Because if you have an aggregate, you know the commands that it will receive, and you know the events that it will produce. So this signature is too broad. So we'll see how we will make it a little bit more constrained. So, but first, some introductions to Akka. So Akka is an actor system, as you probably know. And the idea of an actor system is to have actors, which are objects that lives inside the actor system, and you cannot manipulate them directly. What you do, you send message to the actor via its actor ref. You don't manipulate them because they will run in different threads, and you don't want the state of this actor to leak to other parts of your system. So the actor system will take care of that for you, and it will give you an interface to talk with that actor, which is the actor ref. Message that you send to an actor goes to its mailbox, and when the actor is ready to pick the next message, it will consume a message. You can have multiple state, and that's the one of the main reasons to use Akka is that you isolate the multiple state inside that actor, and you take care that there is no other thread that will be accessing this multiple state. So it's a safe way of having multiple state in your application. And one important thing, and by giving this talk a couple of times, I realized that people don't get it at first, that when you instantiate an actor, it stays in memory, unless you kill it or it terminates by itself because it calls the method terminated and terminate, and it will stop. Otherwise, it will stay in memory. And of course, we have to take care of that when building our application. And there is one plugin, a plugin in Akka called Akka Persistence that you can use to persist a message that you get from your actor, in your actor. But in our case, we will not persist the message that comes in, which will be commands. What will persist are the events. So a command will be sent to an actor, it will process it, produce an event, and it's that event that will persist, not the incoming message. Okay, so how it works more or less with some visual help. So imagine what we see here below is the receive method of this actor, and it's actually a partial function in Scala. I will probably, if we have some time, I can show in details how it works exactly. But basically, it do a case statement, and it check if the message that comes in is some message, it will call that method, it will print that line. Otherwise, if it's another message, it will print another this other message, or this other line. And so in this actor here, I'm configured it to react to only two messages. But if I send a message that is not defined here, this actor will not crash. If you have a partial function in Scala and define it for some message and another message, and I send a totally different message to that partial function, it will crash. A partial function does not accept a message that are not defined in its domain. But what Akka will do, it will there is a fallback. So actually, if the message is not defined, it will send that message to that letter queue. So your actor will not crash if you send a message that is not appropriated to him. So how it works? Outside the actor system lives your actor ref. And that's what you have to communicate with your actor that is inside the actor system. So you send a message via actor ref to the actor, but that message goes first to the mailbox. And that happens on the thread of your application, okay, where your code is running at that given moment. On another thread, the actor system will deliver that message to the actor. And then that message will be processed by this receive method. In the meantime, other messages may arrive, and they will be added to the mailbox, and your actor will not consume them until it finishes with the first message. So once the receive method returns, another message will be delivered to your actor. So by doing that, I can guarantee that my comments from my aggregate, they arrive in a given order. If I use Akka for my CQRS application, I can guarantee that the comments arrive in the given order and that my events will be produced on the right order. So the first comment arrives on my mailbox and will be the first to be handled. As a consequence, the event produced by this first comment will be the first event on my event store as well, and so on. It's a little bit more complicated than that because we'll use features when validating our comments, and I will show how to solve that. But the basic idea is that you can use Akka to that system to make sure that your comments arrive and they are processed on the order they arrive, and that your aggregate will not be validate a comment before it finishes to validate the previous one. And that's very important because if you want to build your event store, you want the events to be on the right order. You cannot have the participant edits happen coming to your event store before the lottery created event, for instance. So little bit more, it's actually the same animation, but a little bit more extended, because now I have the event store here. So imagine that I'm now have this actor system for a lottery application, and I start with a create lottery message. That message is put on my actor's mailbox, which is my first command, and then it's delivered to my actor. And what I'm showing here inside my actor, I put that behavior thing, which is actually something that I will implement for this specific actor. And it will validate that create lottery command, and if it's a valid one, it will produce the lottery created event. And then I will persist it. What I will persist is the event. Now, once it's persisted, I can apply it and produce my first state. And the lottery is the state that lives. The lottery aggregate is an object living inside my actor. So imagine that system crash just after I save the event. Well, and that I never get the chance to apply it and create the lottery inside my actor. Well, it doesn't matter, actually. It's not a big issue. What is important is that I save the event. If I save it, it happened. If it never gets to the persistence store, so it never happened. So if my system crash when it's validating, and just before saving it to the persistent, then I consider it never happened. Of course, the user will get an error from that, and he'll see it. Okay, this event my command was not accepted. But if the event is persisted, then it's considered to have occurred, and your application, you don't need to apply it to aggregate. If it crashed at that moment, your application when your application restart, will replay the event, and then you have the first state of your aggregating memory. So then comes another event, another command, and again the same thing. It's validated against now the current state of my aggregate. It produces a new event. I put it on store, and I apply it. So that's basically the flow inside Akka that I will do. I will use Akka Persistence to store my events on my event store. And by the way, there are many different plugins for Akka, so you can choose which kind of storage you want to use. I use LevelDB on my demo, which is easy to set up, but you have a Postgres, you have a Cassandra, many others. So, as I said, an actor stays in memory. Okay, so if it stays in memory, I need to have a way to find it on my memory space, let's say, and I need a way to remove it as well, because if my application keep running and I'm creating lottery, each lottery will be an actor in memory, and then at some point I will have a out of memory error. So I want to manage that. So what we do is we create we have another actor that I call the aggregate manager, which takes care of all the aggregate actors for lottery. So it will create aggregate actors for given lotteries by ID. So it's the entry point for this specific type of aggregate. It will manage its children. It will create the children for it. Every message that I send, when I send add participant, I have to say add participant to that lottery by ID, let's say. And the aggregate manager is the one that will get that message first, and it will forward to the other actor. Okay? And at some point, it will remove children from memory. And there you can have different strategies. You can say, I don't want to have more than 10 at the same time in memory. Or you can say, if there is an actor that's not getting message for quite some time, I just remove them. Or if there is a lottery that is run already, and it doesn't make sense to have it in memory anymore, so I can remove it. So it's up to you to define how you remove them. But the whole idea is to have an aggregate manager that is responsible for all aggregates of that given type, and it manages the creation and the termination of all these child actors. And then one last thing about Akka Persistence is that you can have snapshots. And the snapshots, of course, I think it's a very straightforward concept. You start with an event, you create your first instance of an aggregate, and so on. And at some point, you decide to save the state of your aggregate. And you do that. Of course, if you have 3 events, it doesn't make much sense because it's very efficient to replay those events. But imagine that you have 100,000 events in one single aggregate. So what you want is from time to time to save the state of the aggregate, and you save the state, but you continue applying events on it. But if your system stops for some reason, when you restart from the snapshot. And what Akka will do, it will reapply when you are reinstantiating that aggregate. It first see if there is a snapshot, I take from there. This is brought to memory, and then it will replay all the events that happen after that snapshot. As such, when you restart, you only replay event 4. Of course, if you think about a lottery application, I won't use a snapshot for that because a lottery has a very short life. You create one, you add participants. Okay, if you have 1 million participants, maybe you want to save snapshot. But if you are doing a small lottery for a group of persons, like here, for instance, you should probably consider not saving snapshots. You just replay them. And once it's done, and there will be no new events on this aggregate anymore. Okay, for how long have we been here? Half an hour? Okay, let's see a little bit more. So, when we are coding a CQRS, the first thing we'll see what the command side, the write model, and we came up with the idea of defining what we call a protocol. And the protocol are the group of the definition of the commands and the events that you define for a given aggregate. So a lottery has a very specific number of commands that you can send to it, and a limited set of events that it will produce. And we have a case class that has to extend an aggregate trait, and we have this behavior. But as we see, the behavior can be a little bit inconvenient to code because we'll revisit the behavior API as the one we saw already. We'll make it reactive, and we see that it's a little bit inconvenient to work with that. It's needed to make it reactive, but in some situations it would be more, to be hard to code with that. So we have a behavior DSL to improve, to make it easier to code. Okay. So before I start with the protocol, I want to go back to this idea of partial function. So you have this. A function in Scala in functional programming, you know what it is. It just maps something, one input. Given an input, it will produce an output. And a partial function is a function that only applies to a limit, to a subdomain of a bigger domain. So if I have here a domain where I have A's from 1 to 4, I have different objects of type A. And I have a partial function that's only defined for A1, A2, and A3. It means that I can transfer a partial function from A to B. It means that I can transform all my A's to a B, but only if it's A1, A2, or A3. And the A4 will be left over. But what the partial function that we have in Akka is a partial function that goes from any to unit. And that's the receive method. That's the definition of the receive method. So as a consequence, I can transform any object to unit, which means that it's like a black hole. Everything that I send there, I can transform to unit, because there is unit is a so broad domain. I can just drop all my data and say, okay, I ignore your message and I give unit back. So the partial function defined in Akka is very broad. So I don't want it. I don't want to code over and over again using such powerful construct. So I want to limit it to my protocol. So let's see what is a protocol. I have a demo that I start here with a product example where I have my comments, my aggregate, and my event and my aggregate. So when I do that, I'm already limiting my space, saying it's not any, it's okay, it's my message will be a domain comment, but it's still all my comments in my system will be of this type. I want comments that are very specific to my product. So of course I have here, I will define my case class, create product, and my event, product created. I have here my product with a name and a price, which is an aggregate. So far so good. And I have a limit implementation of my behavior, which is not exactly the same we saw on the slides, but for demo purpose, I keep it very simple here. So let's say I have this validate from commands to events, and then once I have an event, I will produce an aggregate, okay? The problem with this, and here's the implementation, validate, I receive a domain comment, and I have to match it. Actually, what I'm doing here is a cast in Scala. I'm just saying, okay, that command, which is a domain command, if it's a create product, then I can generate that event. And on the apply event, I will do the same. The problem with this implementation is that this line of code here compiles, because my validate method is typed to domain command, okay? And that's too broad. And of course, I can make the mistake of sending to an aggregate a message that's not the message it is expecting. And this call here will compile. And although it's a def in Scala is a method, so I'm not calling that, but it still compiles. So if I run that, it's just okay. It's only when I really call that method, which is a runtime, that happens only at runtime, that I will see the error. And the error that we see here is that this validate method is receiving the command, and it's not matching that. So to match it, I have to write something, say, okay, invalid comment or something. But I want to have a better way of coding my behavior, okay? So, and why I want a better way to code my behavior? Because I want to solve that problem here in Akka. The thing, as I said, Akka is very, very powerful. But the CQRS application, it's very, we know very well what are the kind of operations we have there. So why I will use such a powerful abstraction as Akka if I know very well what can happen in a CQRS application. So what I want to do is build on top of Akka something that is very constricted, that only does CQRS, and that only accept a message from my given aggregate, only comments from my given aggregate, and only produce events from that given aggregate. And so I need Akka to do all this complexity stuff related with persisting, replaying events, saving snapshots, but I don't want to code over and over again on that level with a function that goes from any to unit. So that's why I need that typed protocol. I need to kill that thing here, because in the REPL, if I do 2 demos in a row on that thing here, it will... I will not code everything, I just copy and paste it here. I thought about coding that, but I think it's better just to go over the code. And my typing skills are not, I don't want to annoy you guys, so let's see here. So I will compare with this one, okay? Here I have my domain event and domain comment. And I directly create my first command, create product and product created. But on that other version, what I will do is I will create a protocol def trait, and inside that protocol def, I put a protocol command and a protocol event. And in Scala, there are many things here behind, and I hope you guys can get a grab of that on that. What we are going to use here is I'm going to give as much as responsibility to the Scala compiler to create a bunch of types that all tightly related with each other, that I can guarantee that my behavior will only accept the types of my given aggregate. So I start with this protocol def, as we saw, and then we have this aggregate, and inside that aggregate I have this strange construction for if you're not used to Scala, but what I'm saying here, this is the equivalent of having something like that, okay? That's the equivalent, but it's a little bit more powerful. What this here is a type parameter, okay? And this here is a type member. And the difference between a type parameter and type member is that type member, you can reference it. So you can navigate your types. We usually navigate over values. We have a value and we do dot something, we call a method, we navigate in the hierarchy. But if you use type members, you can also navigate through your types. So I hope you guys will get a better understanding when we go further with the example. Then I define here my protocol, product protocol, and my create. Those two case classes now are defined here inside that object. That implements the protocol def, and then inside that protocol def, I have access to this protocol command here, okay, and the protocol event. So my create product is not equivalent of any domain command. That create product is an extension of a protocol command that is defined inside my product protocol. So it's not any domain command, okay? Then I define, and the same for the product create. Inside my product, I have my product aggregate. Now I will bind it to my, I will actually define the type parameter. What would be the type parameter? I'm defining my type member now. If I say that an aggregate must have a protocol inside, what I'm saying here is that the protocol of a product is that one. So I'm binding that protocol to this product protocol. So now I have an aggregate, and I have living inside it the types of its protocol. And I'm using type member for the sole reason to be able to navigate over my types. So what I'm doing here, there are two kinds of type members. The first kind we saw is the type, this one here, which is an abstracted one. So it is not yet defined. I'm only saying there must exist a protocol that extends protocol def. It's still abstract. I materialize it here, I define it here inside my protocol. And another kind of type members are just alias. I'm just saying here aggregate type equals A. So A is equivalent to aggregate type. It's just an alias. And I'm creating here two other alias. I'm saying a command is this one, which is very strange construction. But what I'm saying here is I have an aggregate type, and inside that aggregate type, there is a protocol. So I will navigate to that type, the protocol type, and inside that protocol, there is a protocol command. And by doing that, by navigating through these type members, I can make sure that this command, when my aggregate here is defined, that command can only be a command for this given aggregate. So the Scala compiler will check that at compile time for me. And then I say my validate is a command. But which command is that? Well, must be of some kind that implements the protocol command inside the protocol, inside that aggregate. And the same for the event. So the difference here is that when I put my product here as a type parameter, that command is now binded to the protocol type, to the protocol command inside that one. And as a consequence, that code should compile. Okay. But if I define this def here, it will not compile. In the previous example, it compiles, only it fails at runtime when I call the method, but here I'm just compiling that method and it won't compile because it will say that that domain command is not a product protocol command. So by doing that, I'm using the type system to define my aggregate and make sure that all my types from my commands and events are no at compile time. And of course, I will take that behavior and I will give to Akka. And of course, Akka still accept any kind of message. But now, because I have those types in the behavior, I can make sure that everything that I send to Akka will be correct, validated, and I get a clear error message if I send something that's not what is expected. So that's what we call a typed protocol. And the next thing is, well, let's see, I think we can do a break now because the next one will be a little bit more extended. It's okay, we come back in 50 minutes? Yeah. So what we see, just as a teaser, what we see is how we will upgrade our behavior to make it reactive. And and I will show you behavior. I will show how inconvenient it will become to have this new revisit behavior, and then I will show a DSL to make it a little bit more friendly to code, and then we start building some stuff as well. Okay, thanks. See you guys in a couple of minutes. So we start, let's say 35, 10:35, 10:20 now. Okay, so now we see our basic operations revisited. And the first implementation of validate, we said, okay, I have a command and I will produce domain events. But on this version, it's a little bit different. I will produce, my first validate command will produce a future domain event. Well, look, back here, I'm using this generic types domain event, domain commands, and aggregate, but as we saw on the typed protocol, this is not exactly what my behavior will be. But I don't want to put here all these type members and type projection complexity. So I'm back to this more generic signatures. But the point here is that this, my first command, when I receive my first command, I will use a future to validate my validate method will return a future. That brings lots of complexity to not to you guys if you want to use that library, but to myself when I built the library. The first problem that we have here is that when I send a message to an actor and I will call the validate method, it will immediately return, even if that future is not yet completed. It will return, and as a consequence, it will pick another message from my mailbox. But my future containing my first event, maybe it's not there yet, maybe it's not on my database yet, but I will be already consuming my next message, and imagine that the next message, the future of the second command, completes first. Then the future, the domain event from the second command will be on my storage before the other one. So that's something that I have to take care. And but why I validate my command and I return a future? The reason for that is most of the case you won't do that. But in some situations you need to do some I/O or even go remotely, which is also I/O, but even longer, you have to make a web call to validate if the command is necessary. And that's the whole thing about having authoritative, where is the authoritative aggregate or autonomous aggregate. An autonomous aggregate is the one that can validate everything that it receives, and the other cases where you have to ask for the confirmation from other systems, or grab information from other systems. And so the validate commands need to be something that is open to asynchronous programming. So that's why we upgrade it to a future domain event. The second type of validate, it's even more annoying to work, is that in some situations, in some rare situations, you want to produce more than one event for a given command. We do that at the Flemish government, for instance, when we load, there is an action, for instance, to load a file full of data. And the file is fully validated, so that's a command, a new file is loaded. But each entry on that file is a new event. So there is a file uploaded command, but then each entry becomes a single event. And that's an example where you can generate more than one event from one single command. And again, so I need a sequence of domain events, and again, I need to wrap it on in a future. On the other hand, the apply event has to stay the way it is. And that's extremely important to keep it like that. Never, never, ever apply your events asynchronously. Because when you are replaying from your event store, you don't want to depend on an external system. You want to have on your event stream all the information that you need to build that aggregate. Imagine if you go to an external system to check the currency of dollar, for instance, the dollar currency, and well, you are replaying your events from 1 month ago, and now your system has a totally different state because the currency changed. So when you your event stream is the single source of truth. So you don't depend on external system when you are reading from that. So that's very important. However, the validate, you may check other systems or do some queries on the database to make the decision if a command is valid or not. Okay, so we upgrade our behavior where we have this validator that has now a future, that returns future. And by doing that, we are also making our behavior reactive, and we are also handling failure. You remember when I sent twice the command run to the lottery, the second one I had to fail there. But I don't want to throw an exception. What I will do, I will complete that future with a failure. So I have a failed future, which will not blow up my system, but will be handled as a failure by Akka. So that's why we upgrade our behavior like that. So, but it's inconvenient to have that. As I said, these are the two signatures that I have, and but most of the time, I go from one command to an event without going to an external system, even without doing some queries on the database. And on the other side, on the validate, when I have already an aggregate, when I validate an update command, most of the time I produce one event. I don't produce more than one event, and I don't do that asynchronously. So this signatures is very annoying to work, because if I code like that, I have to wrap my events. On the first case, I have to wrap my event every time in a completed successful feature, because I need to give a feature, but it will be already a completed feature. And on the other case, I have to put it inside one sequence containing only one event, and then taking that sequence, put inside a completed feature again. So what I want is to have those signatures as well. I want to have a validate that goes from a single command to an event. Then I want different validate versions for the update case, where I go from one command to a domain event. When I go from one command to asynchronously, asynchronous method that goes from one command to a future event. And I want a domain commands that produce more than one event. And of course, the first two as well, that are on top. So what I need here is lifting. And lifting is a technique in functional programming where you take a given signature, a given method, and you change the return type of the. Actually, the word, the term lifting is used in many situations in functional programming, but one of them is when you have a method, a function that returns a type, and you bring whether only the return type to you lift it to another type by wrapping it inside another one, or you can also lift both, not only the return type, but also the input. But in our case here, I only need to lift the return types of my functions. So I need to lift them all, but it's hard to lift actually, because they are partial. They are, as we saw on the previous on the typed protocol. I have pattern matching, and I can do lifting if I go for partial functions, but still I will need some extra methods, and well, I will show what I have built to solve that. And there is one more advanced Scala thing there behind, which is called magnet pattern, and that's the bonus for today. If we finish everything and we have time, and after the questions, and I can show how it works, probably we won't have enough time to show that. But if you guys are interested in understanding the magnet pattern, I can give a demo on outside. If we can do it here, we'll see. So let's see our behavior. I have here, okay, this guy I can just revert. This demo is gone. This guy can go. So now we go for our, no, this one is good. So I have here a lottery, aggregate. I will first go to through the methods, and then we implement part of its protocol, and then I will show the behavior DSL, okay? So the lottery, it's very simple. I have a name for it. I can add participants, very simple. It's just a name of a person. And I may have a winner at some point, okay? I start with no winner. I have methods on this aggregate that will always manipulate, add things or remove things, and return the same lottery. So that's a case class. It's a multiple objects, as we know. So these are the operations. And then I need here to define my protocol. I have this lottery metadata. It's something that I added to my library. That's something that helps me do lots of things. And on every event, I add this lottery metadata. It's not very important for now to understand that. It's just specific to what I'm offering my library. But of course, I would like you guys to use that and contribute. But the goal here is not to make you use my libraries, to understand what is CQRS and how you can use it with Akka and eventually build your own. So in my case, I have this metadata thing where I have some information like the event ID, the date it happened, I have some tagging, and so on. And I will just add it to, amazing. It seems that's, wait. I move here. Okay. You know what? I'll just go here and I will show the code like that. So I will not code live, as I promised. So I have this lottery command, which is, I'm here inside the protocol. And I will define all the commands that I can send to my lottery, which is the first one, create lottery. For a given name. Name is not that important for the lottery. And then I have the add participant, and then I can run it, okay? And on the other side, I have these lottery events, which are the specific event for my lottery, which has this metadata over and over again. All of them you need to have the lottery metadata. And I have two events. no, 3. I have the lottery created, participant added, and winner selected, okay? Which maps to the events that I can send here. I remove here the remove participant because, yeah, for the demo it's not that important, but I could also have such a thing. And then comes my behavior. And what I want from my behavior is just a method here that I implement on my lottery object that will define what can happen. And as we saw, we have two situations. When I'm constructing for the first time my aggregate and when I'm updating. So I create a kind of DSL where I can say, okay, I want a behavior for lottery. And when I'm constructing, I can do two things. I can process commands, and these are the commands that I will process. I do, here's a partial function that I'm sending, giving to this process commands that defines two matches. If the lottery has an empty name, then is a command exception. Name cannot be empty. And if it's I learned that from other Devoxx talks, you know, when she comes, you have to do something funny for the picture. I hope it was funny. Yeah? Okay, so the other case is, okay, I have a lottery command and I will produce that event. And then I accept the commands. The definition, how I accept a command, well, what I will do from that event, I will produce my aggregate. So that's my construction, which are the first paired, validate with one command, and they apply with only an event. Once I'm there, and as you see here, I'm returning two different types. And how is that possible? You may think, I'm defining here a partial function from commands to any, and I'm doing some reflection to see if it's the right one. No, I'm not. I'm not doing reflection here to decide which one. What I have here is on this DSL, I use this magnet pattern that will define some types that I can return. And it will do the right conversion for me. So if I just return here a string, this code will not compile. I can return on my DSL, whenever I match something, I can return a try, a Scala try. I can return an exception immediately. I'm not throwing the exception, I return the type. I can return the exception, I can return a failed future, I can return a future, and of course a completed one, failure or not. I can return a sequence of events, I can return an event, and so on. So I can return, actually, I can define here all, I can return all those types, plus all kind of sequence from the Scala type, Scala library, and also the tries, a try, which is actually a try. It's we can see that as the synchronous version of a future. At the end, the future reserves as a try, but in the future. Okay, so that's how I will define my behavior. And then on the other side, when I'm updating, then it's a little bit different. I have now two parameters. I always have my command and the aggregate. On my first case, I say, oh, this lottery doesn't matter what is this. Doesn't matter what is the command. If my aggregate has a winner, I will not accept that command. So what I'm saying here in my behavior, if it's run, I have a winner. I don't accept any command anymore. You can also imagine you can do here logical deletion. You have an aggregate, at some point you delete it, but what you do, you mark that aggregate as deleted. And then the first command that you put, the first match that you put on your process commands is, okay, if it's ever deleted, I refuse any new command. Remember that in a CQRS application with event sourcing, your event stream, your event store stays there. So it's not because you deleted that your aggregate is not there. If you replay, it will your aggregate will come back to memory. You apply all the events and you deleted him again. So that's how it works. You will not delete the events when you delete your aggregate. It stays there. So it's better to take your aggregate and say, okay, there is a possibility to delete this guy, and I will put a flag here, say this is deleted. And then once it's deleted, we take care that it will never accept new commands, because it won't make sense. So in our case here, once it's run, I have a winner, I cannot accept it anymore. And the other case is when I receive the run command, but I have no participants. So that's also an error. I cannot accept this command. So I put those two guard conditions in the beginning. The other case is when the participant is already added. I will not allow you to subscribe twice to the lottery. So I send that exception as well. Could be a command exception. I don't remember why I put a illegal argument exception here. I was trying something different, but could be a command exception. By the way, here the DSL will accept any throwable. So you decide which exception you throw, and does not need to be a command exception. And then the other two are when I add a participant, and when I select one. And this select one here, when I pick a participant randomly, it will never happen, but it could fail. It could fail if I forget to this one can fail, because I will try to pick a participant randomly and I have nothing, and it will give me a failure. So that's why this method here is return me a try, because this operation here can blow up. So I wrap it in a try, it can be a failure, and as a consequence, what I do here, if it's successful, and will probably be because I'm guarding that here already, I never run it if I don't have a participant, but okay. I will map it, I take the winner that will be picked, and I put on the winner selected. And that method here, if you can see here, that it's return me a try of a winner selected, that call actually. So my DSL here is also accepting the try. And but as you know, from here, the type that I'm lifting all these methods to the two basic methods that I have. So what I'm lifting here is a try to a future of a sequence of a domain event. So I have a try containing a winner selected, but it will become a completed future with a sequence of events with only one event, which will be winner selected. That's the signature that I'm targeting on my lifting, okay? And of course, from a try, as I said, a future and a try, they are very close to each other. When a future completes, actually it has a success of a failure. And a success and a failure are tries. They implement extensions of the try type. So you can easily, from a try, build a completed future that can be a failed one or a successful one. So, but that code is inside the DSL. So when you code here, you only deal with this case. Of course, you could add logic here. I prefer not to do that. I prefer to put my logic on the aggregate. It's the best place to add your logic. And I just do the mapping. That command, you call that method. That command, you produce that event, and so on. And when I apply the events, I'm just doing the same here. I could have a specific method in the lottery to add the winner, but I just do the copy here. So once I'm here, I take this behavior and I give to Akka, and we'll see in a while how it works. And the actor, my actor manager and my aggregate manager and my aggregate actor, they are already coded. We code it. So you don't have to think about it. You only think about the behavior. Okay. At some point, you have just to create an aggregate manager for the lottery with this behavior, and everything will work as expected. But what can I get from here? Let's see. Okay. Okay. The nice thing about this, I will just remove that guy for the moment. As usual, before a talk, you prepare your stuff. And yesterday night, I tried to play again with that, and I realized now that I mess up with my repository. So the code that I was expecting to see here, for some reason, is not what I was expecting. So maybe that last beer caused that. But okay, I know where I am now. So I will remove all these methods because I want it to be more interactive that you see. I have something that I call in my library that I created that I call a write module support test. And I'm here using Scala test. And what I want to do, of course, we know we have an we have a validate command and then apply event. But then on the test, I don't want to deal with that. I just want to have to say I have here all those commands and I will send. And what will be the result of that? Okay, so I enrich my behavior with a method which is not there. In Scala, you can extend your class with extra methods. So I do that only on test. This apply command does not exist in production code. Okay, what I do is I send some commands. The first one, create a lottery, and then add participant, to participant, and then I run it. And of course, since the validate is a future, will return me a future, the apply command here will also return me futures. I cannot avoid it. But what I will do is I will validate the command, and if it's valid, I will apply it. But since I will have a future, I will also have an event in the future. So my return type here, I will just remove that for a while so you can see. The return type is a sequence of events and a lottery. Sorry, I removed this guy. The return type is a future containing a tuple. In one side, I have all the events that I apply, that were applied, and my aggregate. But that's test facilities, and that's not. So this future value here, it's an extension from Scala test, and what we'll do is once the future is completed, it will give me the value of that future. So I don't have to deal with a wait code in my test. So what I have here, all the events that were applied, and I have my aggregate. So because my behavior is defined totally outside Akka, I can test it without using Akka. So I'm just purely testing all my commands here. I start with create lottery, add participant, and run it. And what I'm expecting when I apply all those commands is to have a lottery that has a winner selected and that has 2 participants. And the test is successful. And let's imagine that I run here twice. So my test failed because it returns lottery has already a winner. So I'm purely testing my aggregate without using Akka. I'm running without any participant, and again, it will fail. Lottery has no participants, and so on. So here I have other implementations. Actually, I have all these implementations here. I cannot run a lottery twice. I cannot run a lottery without a participant. And I cannot add twice the same participants. This all should fail. And the first one, then there is another kind of support here that is the read model. But I'll not show you that for now. I will show you first explaining what is the read model actually. Any questions so far? Yeah? Yeah. Well, no, it's not possible. When I receive an event, a command that produces more than one event, I will only apply it. My aggregate will only be ready to receive new commands if all those events are applied. Yeah, but the here in the test. You mean, or in general? Well, what will happen is that when you receive a message in Akka that will call a method your reaction to that message is a method that you call that returns a future, you're not allowed to, in our case, we don't want to process new commands. So what we will do, and I hope I will be able to show the details, but what will happen is that you'll tell your actor to change its behavior. So you say, I have here a future, it needs to be completed. And in the meantime, any command that I arrive, I put aside. And only when that future completes, you change your behavior and you start to accept those commands again. So actually, you go to a busy state, say, I'm waiting for that future, will bring me one or more events to complete. And when it happens, then you receive that as a message and say, okay, I get the events, I will persist them. And when it's done, one or more events, doesn't matter, then you say, now I'm ready to process new commands. So the Akka will give you that functionality. And so two features in Akka, actually. One is the become, where you change your receive method. You have this receive where you define your function that handles your message. You change that message. Say, from now on, I'm not accepting those messages anymore. I'm only waiting for my events to come back, to complete. And in the same time, you have to say, but if I get, in our case, new commands, for each comment that, for any comment that I receive, I will stash it. Like in Git, you stash things. And when you are ready, you unstash them all. And then you pick all the messages that arrived in the meantime, and you put on top of your queue. And then you start again to process the comments. So that's how you deal with asynchronous call inside an actor. Because if I do a validation, it will be completed in the future, and I start to take the other command, it can be one event or two events, I will certainly come into a situation where the events will be in the wrong order. So I have to take care of that. Okay? Good. So now I have my aggregate, and I put all those events on my event store. Pretty cool, but I need to produce my view. And on the view part, our first project at the Flemish government, we implement our own event stream producer, let's say, of a reader that could read our events from the storage. But since I think 1 month ago, since Akka 2.4, there is an experimental model. Very experimental. I was beaten by that many times already, because we have our own plugin that use Postgres and Slick, which is a library for persistent relational database, and JSON, play JSON. We have our own plugin for Akka Persistence, and then because of that I had to implement the query part, and it's a moving target. Well, when I was implementing, they were not changing the codes, but you can see that there are still things that has to be polished. But what it basically does is you define a query and say, okay, I want events with this characteristic, and it will produce Akka stream of all these events, with all those events. And an Akka stream is a reactive stream in the sense that I can, as consumer, I can say, wait, don't send me events now because I'm busy here processing those events. So on the read model, we'll code what we call a projection. So a projection is what read events, receive events, and make projected on views. So one important thing is that differently than an aggregate is that on the projection side you really have a snapshot each time. An aggregate you can choose to only generate a snapshot from time to time or never generate a snapshot, but a view is a snapshot. And the idea of the view is to have optimized table, query table, to give you your read model. So you usually try to go as flat as possible, denormalize the table to optimize the query. So if you have a complex object, you probably on your view side, you just flat it as much as possible. You don't need to, but it's the best that you can do, actually. So, and it's also important, the actor that will generate those views, it needs to hold an offset. Because it always needs to know when it processed, which was the event that it processed last. Because tomorrow when you restart the application, because you restart the application every night, no? So when you restart the application, you start to read from that last, the next event after the last processed event. So that's how you avoid that your views are, you don't have to replay them all. In my demo here, I will replay them all, because I'm using a repo, in-memory repo. I'm not using a database to save my views. So every time that I start my application, I want to read them from scratch. If I was starting from an offset, I restart the application, I will not see all the events. So my view will be corrupted. One more thing about the views, and actually, when we started doing CQRS, we did a lot of brainstorming, read lots of resource, and said, okay, we know enough. Let's build it. And we started, and of course you start with your command side. But then when you start coding the view, you realize it's much trickier to code the view than the right model. And one of the things is that when you receive an event from your event stream, you want to you must be able to process it. But it can happen that your database is not there, that you have a failure. So at that point, that event will not be processed, and you cannot process the next one, because you need to process them to consume them on the right order. So if your database is down, your actor will die. It will get an error, it will die. And then Akka, you restart it again. And you deliver the same event again. And then you fail again. And then it will keep looping. So what you have to do is to make sure that, okay, you must be able to identify when your event is not being consumed because a system error that will be solved sometime soon, or it's failing because of a programming error. If it's failing because of a system error, okay, you solve it somehow, we hope. It's something that can be fixed without redeploying the application. And the only thing that we have maybe eventually need to make sure is that we will not be retrying over and over again, that to give some time to your system to let's say, within 2 minutes I try again. You have to configure like that. But if it's a programming error and you stop when you're processing events, then you have a problem, because you cannot fix it like that. You cannot fix without deploying a new application. So you get an event, you cannot process it, you fail it, your actor dies, and then Akka will reinstantiate that actor, redeliver the same event, and you fail again, because the failure, the programming error is still there. So you should be able to identify when you're having a system error and a programming error. And if you're having a programming error, you should be able to say, okay, that's how life it is. I will not process that event, and I go to the next one. But of course, if you do that, you need to be notified about that. You need to know that you're dropping an event for a good reason. Otherwise, that given view will be corrupted forever. So you need to know that you're dropping one event in order to process the others. If you don't drop it, what will happen is that you block all your system, because you always be trying to process that event that is producing an error, while the other events coming in your event stream, you never get the chance to produce a view, to update your view. And of course, the view from that specific aggregate that is failing, this is corrupted. This one, you drop that event, the next one will be, maybe it will fail again, or maybe it will pass, but that view is corrupted. But the views from your other aggregates will not be corrupted. And that's so you have to cope with that in some situations when you do a programming error, you may have a view that is corrupted. But then, since you have event storing, event sourcing, what we'll do is, okay, you fix your system, and you restart your application, and you say, my offset is 0. I will replay all my events and I will produce my views from scratch again. And then that view that is corrupted will be fixed because you fixed the error. So that's how you do it. So you need to know when you fail while consuming an event on the view side, you need to be able to identify which kind of failure you have. So how basically in a visually how it works. So I have my event stream and I have a projection actor, which is just another actor in my system. Don't need to, because everything that I have shown here, you can also do that without using Akka, but the goal here is to use Akka. Eh? So this projection actor is a subscriber of an event stream, okay? And for each event that arrives, it will, so it starts to read from the event stream, and for each event, the event is delivered to that actor, and it will send to that projection. The projection, again, like in the behavior, I want to have something that's totally Akka agnostic. So it's a small class that I say, I have here a method that accepts those events, and I will do something with that. There's no Akka involved. So like the behavior that I will put it inside my aggregate actor, I have a projection that I will put inside the projection actor. The projection actor subscribes to the event stream, and for each event, it sends to the projection. The projection will then do something with that. And then I update the pointer in my projection actor saying, I process event number 1. And then I process the second event and so on. And on each time, I will be producing, updating or producing new views. So basically, that's simple as that. Of course, that's too simple. You can imagine that you have other situations where you have some more complex situations where you have 3 aggregates, but if you have only one projection actor that is able to produce views for all those aggregates, then if you have, let's say, a product that's very fast, very performant to generate a view for a product, it will produce products, take event, produce a product view, and the next event is a customer. But let's say that to produce a view for the customer, it's a little bit more complicated. It means that this actor will be producing the view for the customer. It takes longer, which means that the events from the product that is on your event stream will take longer to be consumed. So if you have only one projection actor, it's actually all the events will pass through him in the order of occurrence, which means that you delay the generation of your views while it's not needed. Of course, you can have one projection actor for each view type, one for customer, one for product, one for order. That's also a good thing. You can also have 2 projection actor for 2 product views. If you have 2 different views for products, you can have them working parallel or working together. Then it's up to you to code it the way you want. And the same way as the aggregate actor, when I'm validating a command, I get a future and I have to wait to that future to complete in order to consume the next command. Here is the same. When I have an event, I'm doing I/O here. That's clear. I will always be doing I/O because I'm right on the database. So that projection returns a future as well. So I'm only allowed to consume the next event when my current event is processed. So here, the projection actor does not accept new events while the projection is busy. So it's the same technique. I get a future back. I put my actor in a busy state. When the projection is ready, I tell to my actor, okay, now it's good. You can consume the next one. So that actor will be consume the stream, but he is controlling the flow of streams. It will not be overflowed by streams coming from the storage, but he do the back pressure. Is that clear? Silence. Should I interpret it as clear or as not clear? So let's see how it is. The projection view. So this small class here, it's quite simple. It's how I will generate my projection view. And it just gets a REPL Well, what is a repo is just an interface, an in-memory repo that I have here, and it has like add, save, delete. Just it has a map inside. It's just for demo purpose. Okay, test is also very useful for testing. So if I have a lottery create, I forward it to that message, to that method, and lottery update event. It's all my update events will extend this trait. That's how I code it. Well, it's very simple. I lottery created. I create a lottery view. And for the updates, I will call these other possibilities here. I think it's there. Okay, but it will never arrive. Okay, so here I'm producing the view. Okay, from the same event. So I have commands, generate events, and here my events will arrive at some point later, and will produce the views. Okay. But for the moment, I will, for the demo, there are two things that I want to show here. I will just, no, you know what? First I will show on the test. So I have also here some facility to test the view. And what I'm doing, I'm initializing here my repo. Again, it's this in-memory repo. I'm giving it the projection. I have that projection. And again, I have a apply events, which is an extension method that I added to the projection for test purpose. And what I will do here, I send all the events that I got from my commands from the right model, and I'm sending to that projection. So I have here a list of events. I will just run over all those events and send to the projection. The projection will produce a view in that in-memory repo, and at the end, when I'm finished, I take the object from the repo, and it should have the same should have two participants and a winner. I can even say the winner. It's an option, I think. Yeah, I can even say that the view in the winner should be equal. That's. So now I'm testing both sides. It's not coming. Let's change a little bit the code. Save. It should be triggered. I'm just testing now my read model, my write model, and my read model without using Akka. I'm just on the command and event level. Okay. I want to give a demo in a running application, and but there is something that I think it's cool to show, so you guys get an insight of what is that exactly. I will change my view here, and I make a partial function, an empty partial function. That partial function here, because the receive event method in my projection is a partial function as well. One important thing that I didn't mention is that the type of my projection is handle event, which is a partial function from domain event to future unit. And the reason for that is why I'm not using the protocol here is because on the projection side, I probably want to have one projection that consumes events from more than one aggregate. So it doesn't make much sense to code something that is limited to a given protocol. The way we work on the view side is quite different. So I want to go a little bit more broad. The reason also why I have a future unit is because it's where the event goes to die. I don't need to. I just produce things. I don't need things back. So that's why it's unit. I don't need the return type here. And it's also a way because if I have a partial function whose target is a type that I can always convert to, I can receive events on that projection, and I can say, okay, I cannot handle this one, but I will not fail. I can do that with a future, actually. I can always say, I will return a failure future. But I can also say, if I cannot handle an event, I return a completed future containing unit. I just let it pass. And that's very useful, actually, because you you define projections for a given domain, where you define some domains, some events for him, and you define another one, and you can mix them. And they can still work as separated, because they will always succeed. Anyway, so that's the signature of the function, the projection, the handle event function in the projection. But what I'm saying here, I'm just saying empty. So when my system sends events to this projection, that function will always say, I'm not defined for this one. Go further. I do nothing here. And what I want to show is that we'll start an application. I will start on my aggregate lottery. I will send events to it. I will prove that it's consistent, that my system is working, but I will not have any projection from that. So you will not see the result. Although my lottery is living and running inside my system, I cannot see it because I don't have a view for that. And then we'll add the view, and then it will restart the system, and we'll have the view. So yeah, here the projection is failing because I make it partial function empty. So let's start again. Oh, let's see if I want to remove my database. That's how I remove database. I just do rm. Well, LevelDB, it's very convenient for demos because it comes just more or less configured. If Akka Persistence, you have to do some stuff here, but it goes very well. Oops. Okay. I have a play application, and then I show, after the demo, I will show how I wire that all together, okay? So I'm running with the tilt, which means if I change the code, play will recompile it, and we'll see we'll be able to rerun the application. I have a GUI, but since I'm doing that for free, I don't do JavaScript for free. So I have a GUI in shell script. So I have here some commands that I will just do some REST calls, so I don't have to spend my free time coding JavaScript. So, yeah, really. Yeah, on my free time, I only do things that I have fun with. So I will just list the lotteries here just to to start the play application. And I have nothing, okay? So let's start. My first command is create lottery, and I hope, let's say, 1 and Devoxx. By the way, there is no prize. You guys cannot subscribe to the lottery, okay? It's just demo, really a demo. So I create it. So it's created, and I can, if I list it now, list lottery, it's not there, because I don't have my view. I explicitly put my view as a empty partial function, so nothing's being sent to my view REPL. Okay, so let's add a participant. Lottery. I give the ID of the lottery. I say John. It's there. I say Paul. I say Jan. I'm just adding them. Okay, Jeff. So still nothing there, and I can run it. It was run. Okay, I have to say the number. So what I'm doing here, I have a controller that gets this ID lot1, and then it sends to this aggregate manager, which is the aggregate manager for lottery aggregate, and this aggregate manager has the list of all childs it created ever. Well, the childs that are in memory. So once he gets this ID, it will look on this, it's a map actually, say, okay, where is the actor for this ID? It takes that actor and sends a message to that actor. If the actor is not there, it will initialize it. So when I restart the application here, the lottery actor for lot 1 will not be there. So when I send the first command to that aggregate manager, they say, okay, it's not here, I have to instantiate it. And by instantiating that actor, it will replay all the events and bring the aggregate on the final state, the last state, known state. And then the command will be applied, okay? So I run, but we still can't see who won the lottery. I can send again, and now it's saying the lottery has already a winner. So my aggregate is consistent, and all the commands is being sent to my aggregate, and it's validating according to my behavior, it is valid or not. But I'm not seeing that yet because my view is turned off, let's say. So let's re-enable that. My play application is compiling now. I will run that command just to kick the play application, make it restart again. And it says, okay, have already a winner. So let's see if I have here my lotteries. And I have it. So now my events were persisted. I fixed my view, I restart the application, and then what the projection actor will do is to start to consume the events from 0 and will produce my view. And what I also want, it's a bit of a silly functionality, but I did like that to show you how useful it can be. I will just, if you see my lottery object, it has name, participant, and a winner. But if you see the lottery view object, it's a little bit more complex. It has the run date, and it has a participant object. And the participant is the name and the date it's subscribed, okay? So why I don't need this information on the aggregate side is because the date that a participant subscribed to a lottery is irrelevant for my business. I really don't need it. And the run date of my lottery is totally irrelevant as well. The only things that I need on the aggregate side is that I have lottery participants before I run it. And once I run it, I select one and I cannot run it again. These are the business constraints. But I may want to have some more information on reporting on the view side. So what are those dates? They are the dates of the events. The date that John subscribed to the lottery is that date here. So this information I have on my event, so I can add it on the view. Same for the run date. The run date here is the date where the winner selected event was created. Of course, you can go much further than that, but the idea is to show that what your view is not exactly what your aggregate is. You can have more things in your view. You can also do some other database queries when you are processing an event and collect even more information from other tables just to build your view. That's the main purpose of a view. So the main idea when we were building that was that our insight was, if I have an aggregate and a protocol and a behavior, and it's well typed and well defined, I can give it to an actor that will understand what is the life cycle of an aggregate in a CQRS application. By that I mean there is the validate and apply when I'm constructing. I have to save the events, and then there is the update and the update commands and the apply of those events as well. When I have already an aggregate and I save those events, and then I will be able to replay those events when I have to reinstantiate my actor. The events are stored via Akka Persistence and are read. That's also important. I don't know if I mentioned that, but I mentioned when I talk about the aggregate manager is that I have one aggregate for a given aggregate ID. I have only one actor in my system, only one, and all the comments goes to him. Of course, if you are in a cluster, you have to make sure that you have only one single a cluster singleton of that actor. It becomes a little bit more complicated when you're deploying that in a cluster. I don't have experience with that. We are not deploying in a cluster at the Flemish government, but I think it's quite obvious that you cannot have the same aggregate living in different nodes in your cluster, because you probably have commands being sent to the same aggregate and on the same time, and produce events that are not in the right order. And as I said, the aggregate consumes one single command at a time. And by that, using Akka, I guarantee that I don't need to have optimistic locking. Of course, I have a kind of pessimistic locking, because I'm piling up all the commands and processing one by one. But since I'm doing an append-only storage, I'm only adding events that must be very performant. So I'm serializing my commands, okay? And I use the Akka query for projections. I'm very happy because we still have 1 hour, and I have lots of other stuff to show. Actually, now I have 1 hour to show really the internals. And that's more the theory. I think I present everything. We can have some questions now, and then we go for a break, and then I will show really the internals, how it happens. For instance, when we need to stash commands, I will show, have a demo for that, and yeah, and some other stuff related to partial functions. So if you have questions, we can try to answer questions related to the theory now. And after the break, we can go for more Scala stuff. I can show really how I'm really dealing with that all at more, we'll see much more code after the break. Questions? Yeah.
What I don't understand is, for instance, if you give the command to run the lottery, you need participants, right?
Yes.
But if I understand correctly, the actual adding of participants is done asynchronously.
Yeah.
So how does it know that there was an event in the event queue to add a participant so that it will be correct in the future?
Yeah. Well, the commands, they arrive and they are piled up in the mailbox, and only. So the question was, I think I forgot to repeat your question, but it's actually similar. The question was, how can I make sure that when I run the command, that the participants are already added to my aggregate? Well, the answer is that the commands, indeed, they are asynchronously processed. They are processed asynchronously on the future, but I will only accept the new commands when that future completes. So when I do add participant, only when I have a participant added event applied to my aggregate that I'm ready to consume the next command. So I send the commands, and they are piled on the mailbox. And then they are processed one by one, and I have to wait for the processing of each future, only when completed. And after the break, I will show you how Akka works, how we do that in Akka, how you make sure that when you are waiting for the result of a future, how can you put your message aside and wait to this future to complete, and when it's there, you start to consume the other message. I have a demo for that. Yeah? Yeah. Yeah, okay. I think it's also a similar question. So the question is why my call is, it's not a similar question. Now I got your question. The question is why it's not my apply method, but the command, the validate command, why it's returning a future if it's already async. If Akka is already async, why I'm putting it on a future, and well, Akka is already async. Why I'm doing that? Why I'm not blocking there? And the answer is that, well, your actor system has some threads from execution context from a thread pool that we use to answer message, to deliver message to your actor. If I block when I receive a message, and if I block there, because I'm doing some I/O or waiting. Well, it's true that my actor system is still processing other message, but there is a thread from my actor system that is being blocked. It means that my actor system has one thread less to consume other messages. And I don't want it. I want my system to continue processing other messages. Of course, this aggregate, for this specific aggregate, I cannot process new message, but I want that thread free so my actor system can scale. So that feature that will validate that command, it will be run on a thread that is not a thread for my actor system. So I make sure that I have, and then it's how you configure your application and you do the dimensioning, how many threads you dedicate to answer message, to handle your message in an actor system, and how many threads you want to have to process, to do other kinds of I/O. So by doing that, I can say that feature goes to another thread pool, will be executed by another thread pool, as such that this actor will return as soon as possible. This actor will be quite off blocked because he's now waiting for the result. But that thread that is an actor system thread will be available to handle other messages. And that's how I go reactive, because I'm not blocking on my when consuming message for my request from my users. So that's the reason. I don't know if it's answer your question. Does? Do you guys understand the goal of avoiding, when you never block inside your actor? If you need to do some I/O, if you block inside your actor, it means that your actor system has one thread less to process a message. So give it to another thread pool. Let this future, that operation be executed by another thread in the future, by a thread that's not from your actor system. So your actor system can still respond. That's the main pattern, actually. Yeah. So how Akka manages scalability? I don't know if I understand your question in the context of this talk, but yeah. Well, so how can I use my commands and my behavior, because they are immutable? How can I scale that? Well, actually, you cannot do much here, because you have to make sure that the ordering of events and commands are correct. So I cannot have twice the same aggregate for the same ID in memory or in different nodes in a cluster processing commands, because I will have they are one single object at the end, and I cannot have I don't want to have an event stream with interleaved events that were validated, that comes from commands validated in with different instances. So I cannot have that. So I will be able to scale in the sense that since Akka is itself asynchronous and easy to scale, I can make sure that I can have different instances of different nodes in a cluster, and each processing receiving message. But then I need to make sure that once I have an aggregate, it's a cluster singleton. On my whole cluster, there is only one instance of this aggregate. So of course, if you have let's say one given aggregate instance that is receiving lots of events, the only thing that you can improve there is how fast you can validate your commands and apply your events. Just to give you an idea, we use Postgres, and we are not using CQRS because of performance. But from what I read about the performance of Postgres in writing, when you're doing append-only storage, like appending events on a table, it can consume about 10,000 events a second. So I think that most of the applications can cope with that. 10,000 a second, it's a lot. So if you need more than that, then I think you should go for other kind of storage that are more performant. But you always need to have your aggregate is only one aggregate in memory, because you cannot allow yourself to have events on the wrong order. So Akka will scale because it's made for that. You can have a cluster, but your aggregate itself, it will not scale it's not indefinitely. It will depend on how fast you can add events to your storage, actually, and how fast you can validate your event. If your aggregate is autonomous, then of course you don't need to go to external system. You always produce a completed filter over and over. So that's very fast, and then you append the time that you need is to append the event. And this operation will be a little bit longer, of course, because you're doing I/O on the storage. But again, if it's append only storage, it should be quite performant. Next question. Yep.
So speed up the process for consuming events, if you have to restart your application, let's say you have hundreds of thousands of events, the only option is to have a snapshot?
Yeah. So if I understand the question is, when I restart the application, if I have to replay everything, well, you only replay. Let's say that I have this lottery here, it's on my system now, and I restart my system, it will not be replayed. I will only instantiate that actor if there is a command coming in for this actor. And then my aggregate manager say, okay, it's not a memory, I have to reinstantiate it. And by doing that, it will replay everything. If I'm using snapshot, it will load first the snapshot and then reapply all the events that happen after the snapshot. But only if there is a new command coming in. It will not reinstantiate everything in one shot at startup. In my situation here, because I'm using in-memory repo, for the view side, I'm indeed replaying everything from scratch, but that's for demo purpose. So on the view side, you don't do that. Actually, you have one role on your storage for each view, and your projection actor has this pointer, and you know when I restart, I process already this event. I will process from the next one, and I will apply the updates. Yep.
You're validating your commands in behavior.
Yeah.
So if you have to do a lot of validation, you're touching a lot of the domain model. You're exposing the domain model to behavior.
Yeah.
Is there a way to get around that?
Yeah, so the question is, I'm validating the commands in the behavior, and it's kind of exposing the internals of my aggregate. Well, the idea, the behavior, it's part of your aggregate. Your aggregate is just a case class with data. You can put actually, you can consider your behavior just part of your aggregate, but why I put it outside, the main reason for that, I don't have a demo for such a situation, is that certainly when you are validating, you may want to have access to some service. And if you put that inside your aggregate, which is your like the case class, I cannot inject service there. So if I put an aggregate, I can do that. But what you can also do is you can have, and that's actually in this demo, what I do is actually all the functionality, it's on the aggregate, on the case class itself. It has method add participant, pick winner, and so on. But the behavior is just forwarding. I just say that one goes here, that one goes here. So, but you can also implement behavior inside that. But soon it becomes very cluttered. So I prefer just to do like mapping. That command goes here, that command goes here, and I have some simple validations. But for instance, if I go back here, we could argue that this one is already too much. That validating that lottery is created or not should not be here. That should be something inside the lottery. But then, okay, I don't have a lottery yet, but then I could have a method in my companion object that does that. But it's okay, I could do that. It's just an option. But then I need to have something that returns a try, where if it's invalid, it returns a failure or a success containing the lottery created. But then you're free to choose where you put your code. Indeed, I don't like to put too much code here. I really try to go as minimal as possible and having the code in my aggregate. But at the same time, I don't think that the behavior should be seen as something apart. They go together. Okay, more questions? Yeah?
Do you know how Akka identifies the receiving messages? I'll explain it. When you have an actor and you send event to projection view or some other actor,
Yeah.
how does it know, how identifies it if it is already processed? I'm talking about some resuming situation.
Yeah. So the question is how Akka identifies that an event is intended for a given actor and how it resumes. Is that correct?
No, I'm talking about exactly once, at least once, processing. If you have a projection view that already processed some message from
Yeah.
the actor, and it fails, you restart the actor, and it gets another message.
Yeah. So how my projection knows, how Akka knows that a given event was already delivered and will not deliver it again. Well, Akka does not know that. It's my projection actor that takes care of that. So whenever I receive an event and I send to my projection, only when that projection succeeds, I update my pointer. And that's also persisted. And then I process the next one. If I fail at that point, my actor dies at that point, then that pointer is not updated and it will be reprocessed. And one thing that probably that I didn't mention, and it's probably the reason of your question, is that the projection, you must be able to make it idempotent. Because it's very possible that, imagine that you receive an event, you send it to the projection creates a role in your database, and then when you go back to an actor and you need to save the pointer that you just processed it, the event, the pointer to the index of the event you just processed, and then you fail it. It means that next time when you restart it, we will process that event again. So you have to take care that your projections are idempotent. So Akka cannot know that you did that. So one way of doing that, but that's not out of the box, is to have that the pointer inside the actor be managed by Akka Persistence itself, and make sure that your Akka Persistence is happening at the same in the same transaction as your projection. But that's a little bit more complicated because it depends on the kind of plugin you're using. If you're using Akka Persistence with a relation database plugin that which most probably supports transaction, most of them, I think. and then you can do that. But even Akka Persistence is not foreseen for that. So our plugin that we have internally, we are now building something that we can do that. But it's something that depends on other infrastructure, like Slick does give you the possibility to define a database operation that's not yet executed, that you can compose to another one and run both in one transaction. But that's a very tricky thing to do, so it's better not to rely on that. In any case, my library is not relying on that. You have to make sure that your projections are idempotent. So you get an event, you need to create something, you have to check if it's already created or not. Custom mechanism?
You are making yourself mechanism.
Yeah. Akka cannot know that. Only if you persist the pointer together with your projection, then you could cover that. But yeah, you could eventually. Well, I offer different ways of saving your pointer. One of them is a customer one. You define yourself how you want it, and so then you could persist your pointer together with your view. And but I never tried, and I think there are some things there to can be some work. It's not straightforward. Do we go for a break? Because then we have 40 minutes, or we just go for code now? Code? That's good, because otherwise we will end up with only 20 minutes of coding. Okay. Okay. So, first thing that I will, I think that was a question that came many times, how I can make sure that I will not process two commands at the same time. So I will show some Akka code that will take care of that. This can go. So I prepared another demo with just Akka. So in this small application, I will what I do here, I have a counter actor, and I will send message to him, 30 message, okay? And if it's even, I will increase my counter. I send a message increase, otherwise I decrease. But I don't want it. Now that's for demo purposes. It's a very silly thing to do. Okay, that's not very useful. But I don't want to go below 0. Okay, so if I can only send a decrease after an increase, and I will send interleaved increase decrease increase decrease, and at the end, my result must be 0. Okay, so I send all those messages to my actor. I will wait for 2 minutes. Oh no, that's timeout, sorry. I'll not wait for 2 minutes. Once I'm giving a lot of time here, it's more than enough. And then I ask for the state of the counter, which will be a future containing an integer. And then on success, I will just print it, okay? So the first implementation is just good enough. It will produce the increase. It will increase, decrease, and you show the results. And I think if I run that, it should be enough. Okay. And it ends up increasing. Yeah, because I changed. Okay, I start with 1. Okay, so I end up with 1. Okay. So if I use this other one, which is a broken one, and we'll see why it's a broken one, when I receive the increase message, I call that method that returns me a future. So it will increase my counter, but in the future. So from that point in time, my actor is ready to receive other message. But because I'm sending one after the other, my mailbox is full of message interleaved, increase, decrease. And because this increase method is returning a future, I will consume the next message, which I will decrease the counter. And then I will consume another message, which will increase. But then all those operations will be completed asynchronously, and I will never know if they will be on the right order. And my counter will be updated not in the right order, actually. And every time, what I do here is I'm sleeping 200 milliseconds just to force a little bit. It's not that it's needed, and more normally, even without that, it goes wrong. But what I do is I send my result. I send a new counter to as a result, and when my actor receives that result, it updates my counter. And in our case here, probably what will happen is I will first have my mailbox full of increase, decrease message, and then lots of results, each updating my counter with the wrong value, because they all come as a result in my mailbox in the wrong order. So that's the consequence of returning a future here, and also here in decrease. The rest is more or less the same, and whenever I update my counter, I will see that message on the log, on the output. So that's just broken, and as you see, it's totally different outcome. And when I process it, even in between, I receive already when in my main method, I'm looping from 1 to 31 and sending all the message. And even there, I'm having already results. My Akka is processing and sending already results, so I have result coming in between the increase and decrease message. It's totally broken. So how do you fix that? So my next implementation is the one implement stashing. And the first thing that we'll do is, okay, if I got an increase message, I become busy. And as you see here, my default method, my receive method equals default, which is this one, is how I start, the default. That's my partial function handling the increase message. I increase, but then I go to busy. And the busy is a method that when I'm busy, I can only answer, I only react to result message. All other message I send to the stash. So by doing that is actually what I do when I'm processing the comments or waiting for the events from that I'm applying to the view. What I do is I go to a busy state and say, I wait to that filter to complete. And when it's there, I receive it as a result in my mailbox, the result of the filter I receive on my mailbox, and then I process it. So if I go back here, I think I didn't explain that on the previous one. I make a filter with a result and I pipe to self. The pipe to self in Akka is, if you have a filter, it's like, you can do that also on the onComplete, but it's just convenient to say, to call like that. You pipe to self, pipe to is a method that you extend, it's an Akka extension for filter, where you add a method that you can pass an actor. And what it's saying is, when that filter completes, take the content of that completed filter or the failure, and you send it as a message to that actor. So I'm piping it to self. It means that when that filter completes, that content here, the result of my filter, will be sent to myself, to that actor, as a message. As such, I will not receive a filter. I receive the content of it. If it was a failure, I get a failure here and as a message. So I receive that result. I update my counter. I become, again, I go to my to my default behavior, which is the initial one, where I receive increase and decrease, and I can also inform the state. And I unstash all. And the unstash all is when you, in the meantime, I've been putting message on the stash. And the unstash all, I just take all the message that I put there and I put on top of my mailbox. So they arrive first, but I put on the side, and then I put it on top, and then I start to process them. And the decrease method will do exactly the same. It will do a decrease of my counter, put on a result, send in a filter to myself, put in a filter, send to myself when it's ready, and it will come here, and I will change my counter. So this actor now is fixed. It's processing the increase and decrease message in an asynchronous way without messing up with the order. Yep.
Well, it will unstash everything, then process one message and stash all of this again, right?
Yes. The question is, it will unstash everything, process one message, and start the stashing again. Yes. Well, but depending on how you code. In that case, yes, I will unstash everything, and then I have them all back to my mailbox. But once I process the next message, what I will do, it will be a decrease, and I go again to the busy state, which as a result will start to stash again. But not necessarily your actor will do that. It can be that you go to a state where you'll not be stashing anymore. In that case, it will process. It's always like that as well. It only process one message at a time, and you decide when you are processing what you do next. Start to stashing, unstash, just continue with the current behavior. But in our case here, indeed, when I process the next message, I go to busy again, and then the next increase message that is there, you will start to stash. So this one should give the same result with a little bit more delay. as the previous one, the first one where I was not returning futures. And so that's how Akka deal with a future. And again, the reason for doing that is that the future that you don't want to block inside Akka. Of course, this is just a silly example, but in a CQRS application where you are processing things really inside, doing some queries on the database or going to external service, then you really want to have that not being executed in the same thread as your Akka system. I have one more thing here. I have two more things. I can show a little bit how partial functions are. I don't know if it's clear for everybody, and certainly if you're not coding yet or a lot with Scala, it can be something new. But that's a very short demo, I think I'll give it. And then I can explain how I built this DSL using the magnet pattern, which is, then it's again a little bit more advanced Scala. Okay, I'll show first this partial function stuff. So partial function is one of my favorite features in Scala. What I did here, okay, I close this guy, kill, go away. So again, I have here a type alias, just to make my signature easy to read. I say there is a partial function that whenever I have a string, I may have an integer, but it's partial. I may have, for some strings, I may have something that is not mapped. So I will start with this receive here. I'm faking Akka a little bit, but if you understand that, you understand how Akka works with these receive methods, and also how my libraries work, because I also define things as in terms of partial function. So I have here a partial function that can maps ABC to 1 and DEF to 2. And all other strings will not be mapped. If you call a partial function with so PF here equals receive, okay? So it's just that one. Let's put it here. I'm calling the receive partial function with a string that's not defined, where there's no definition for this string. So what will happen here is just blow up. This partial function is not defined, and it just will not work. There's no matching for this one. So of course, if I send ABC, it maps. So when you have a partial function, the first thing that you have to do before you calling it is to ask if it's defined for the object that we want to pass. So we do that by so now I'm sending here ADS, so the value here, and then we first have to ask, are you defined for this value that I'm planning to pass? If not, if you are defined, call it. Otherwise, I will do something else. That's how you work with partial functions. But what I want the insights that I would like you to grab from here is that if I have something that I can fall back, I can create from a partial function a total function. So in my case here, I can say my fallback is for whatever that is not defined, for every message or string that is not defined, I go for 0. And I can compose one partial function with another. So what I'm doing here is use the receive, where I define it, is defined for ABC and D and F. Use that one, but if it's not defined for the string I will pass, use the fallback. And the fallback is a kind of catch-all. So now my PF function, and that's what the one I will call here, my PF function is now defined for every kind of all kind of strings, because it's the composition of the receive, ABC and DNF, defined for those two, and another one that catches all and brings everything to 0, transforms everything to 0. So this one is okay, and ADS becomes 0. So from a partial function, I have a total function. If I can build a fallback for it. So when you have Akka that has any to unit, is because and since you know that you can, I don't know if you know that, but then you learn that now. If you send a message to an actor and it's not defined, you don't have that message not defined on your receive message, your actor will not crash. That message will be delivered to a mailbox, to that letter mailbox. What I'm saying, actually, I'm not sure how it's implemented really at Axis. Probably Akka does ask to the receive method, are you defined for that one? And if it's not, it forwards to the that letter box. Or there is a fallback. Probably it's the first one. But on my system, when I define my partial functions, I have a fallback. So if you forget to define your command, what you get a fallback. And the fallback will be a failure feature saying that command, showing the command, was not defined in your behavior. Okay? So that's how I make sure that the aggregate actor will not break, but you get a useful message back. So if you send something to that aggregate actor that's not foreseen, a command that's not from his protocol, or any message that's not expected, or something that you forget to define, it will say, this one is not defined for me, I cannot accept. While if you do that in pure Akka, it will just go to the that letter queue. You can only do that when you put some more types. So if I go back to my I will remove my behavior. I say that I just put it here in comments. And instead of returning the behavior I'm defining here with the DSL, I return an empty behavior. And an empty behavior is something that will just do nothing, okay? And if I say create lottery, let's put another Devoxx. Here I have an empty behavior, so it will, oh, didn't compile it. Oh, it be, oh, it accepted. Okay, I'm on the right project. Yeah. So first I will show what happens if I start with an empty behavior. Of course I cannot accept, but the Akka will give me the right message, clear message back. Okay, this one is just the list is on the this one. It's not getting my thing. Where is the error? Yeah, always when you do demos of things, I know why. Okay, I'm on the wrong object. Because I know where I have to go. It's here. I'm on the wrong lottery object. Amazing. The thing is that I have my project, which is from CQRS, included as a dependency in a SBT. So, and there I have another demo for lottery, and it's speaking from there. So I make sure that I open the right one, which is here. You see that the behavior is still defined here. No, behavior, empty. Let's say it like that. So it's saying empty behavior can't accept commands. So my actor is not failing, and it's giving me back a decent answer. But I can go further. I can just forget to implement one of my, to react to one of my commands, this one. So here I do have a behavior, but I cannot add participants. No, wait. Yeah. I cannot add it. No, I remove both to make sure that I will not fall here. Okay. So create lottery. It's created. I can do lottery add participants. Was lottery John. And it's an invalid command. That there is nothing that can handle this one. If I was using pure Akka, it just disappear. You see some log saying that the command was not delivered to the actor, but here I know that I can react to something else. And how I do that, my behavior DSL is defined in terms of partial functions. And because of partial functions, at the end, I add one more. I have my definition, and then I have a or else that I say, but or else, if you send a message here that are not matched, send a message saying, make a failed future saying that this message is not defined. So I have a better feedback. So that's all about partial functions. Now I will show you guys the ugly part of a DSL building, which is a piece of code that have changed quite a lot. I have a new proposal from a friend of mine that I think it's here. Luke, are you here? Yeah, I thought it was you. Because I have some state here, I use vars, and of course we can do better. But anyway, this is the old version. It doesn't change the usage. What happens here is that I have a partial function that my validate is something that goes. Let's take the first validate method. It receives a command and has to produce a future of event. But I want two variations. I want a future of event or just an event. So I have two types, but I want to lift. When I have only one event, I want to lift it to a future. So one way of doing that, and you can do that at compile time, one way of doing that is returning any and doing some reflection and find out what you have and wrap it the way you need. But of course, you can put it on, give the Scala compiler some, it's powerful enough to do it for you. So what I will do is, my partial function here, I think I'm on the creation one. Yes, I'm on the creation builder. My partial function here is a partial function that accepts a command from my protocol. Again, I'm using these type projections the way from a type memory that I can navigate. So it's not any command, it's the command from my protocol. And I go to event magnet, which is something that only exists here inside that code. That event magnet for the creation is something that has an apply function that gets nothing but gives me a future of a protocol event. That's the type of my partial function. But when I'm coding here, I'm not sending those types. I'm just sending the protocol event. So what we do here is that method, process command. The Scala compiler knows it's expecting a command to event magnet. It knows it is expecting this type. But since I'm passing a wrong type, what the Scala compiler will do is, okay, it's not what I was expecting, but can I convert that event to a magnet? Because I need here magnet. So it will look on its implicit scope and see if there is a converter that can take an event and make an event magnet for it. And it will find it, and because it's defined inside my DSL, well, the DSL is here, and the magnet is here. There is this companion object. In Scala, you have this implicit conversion, or I didn't give an introduction to that, but you can use implicit in many ways in Scala, in two ways actually, when you need to pass something implicit to a method, which is another kind of implicit, and when you need to convert something. And here I'm using implicit conversion, which is a tricky feature. I don't recommend you to use that everywhere. It's nice when you're doing a DSL, but not when you're production code. Not when you just application code, don't just mess up with your code. It becomes very difficult to follow. But if you're building DSL, it's one of the nice places to use that. So use that with care. So what happens here is that I want to go to an event magnet type. So the companion object of this trait, which is here, define for me some conversions. And the first one that I need is, in my example here, is where it was. It's here. I have just an event from my protocol. So this one will kick in and say, okay, there is an implicit conversion from protocol event to magnet. And what does this implicit conversion is just give me a magnet, which apply method wraps that event in a completed future. So by using the implicit system, resolution system, I find which is the converter from an event to a magnet. And now I have a magnet that if I call it, it will produce a future, a completed future with my event. So that's how I do some tricks on my DSL in order to avoid you to write code that will be two variables. If I don't have that here, since my final method should be a future of event, I have to over and over again do something like that. Well, not if my I have to do that over and over again. I don't want to do that. That's too boring. This one you also compile. Why? Because I also have one that match for every future event gives me a magnet. And watch this magnet does nothing. There is no lifting here. They apply, just return this one because that's the final type that I want. I also have one from a try that given a try for an event, will make a completed future for this try. And also one given an exception, any exception, I make a failed future. So that's how I can, at that level here, have a DSL where the target type of my partial functions can vary, and I still have the compiler to help me resolve that. And then I have also, so for when I'm creating, I have one for protocol event, one for a try protocol event, future protocol event, and for exceptions. These are the cases I have here. And the update is a little bit more complex because I have many other options. I have a protocol event, I have a sequence. If I have many events, I want to wrap it in a future. If I have a try with one event, I want to wrap it. If I have a future with one event, I need to put it inside a sequence. And if I have a try with many events, I need to put it on a future. And this one is the one that there is no lifting here. I'm not transforming anything. I just have the right type, but I just have to put it in a magnet. And the last one is the exception. So by doing that, I have this easy to use DSL. But hard to debug. That's the drawback of doing that. When you do that, you get such an error. Found string required event magnet. And if you are not aware, you say, why event magnet? I was planning to send an event or a future of event. What is this event magnet? It's not clear. So that's the drawback. So it's something that you have to but again, this is just a DSL. What I need here is a behavior. You can implement behavior yourself. That's just a facility to generate using a DSL that thing here. That's my behavior. That's the object, my target. So that's the DSL that we built. But if you don't like, you can also build your own DSL or just use the behavior as it is. Okay, that's it. We still have 10 minutes. Some more questions?
Yes, the implicit conversions, I guess they can also go directly to your target type as you're using a magnet in between. I'm not familiar with the magnet pattern, but is that to prevent unwanted implicit conversions directly? So do you explicitly say, I want that magnet in between?
Yeah. Yeah, it's a good point. I think I didn't try it, but I think I could do that with implicit conversion directly, without passing through a magnet. But the question is...
Maybe then you get unwanted side effects if you have the implicit conversions that kick in when you don't want them.
Yeah, yeah.
Say you do want a magnet.
Yeah, it's very possible. It's very possible. I didn't try it. And by the way, my first implementation of this DSL, why I need such a thing is that if you don't do that, the Scala compiler cannot recognize what is the target type of your partial function, and as a result, you need to have different methods. It it applies many events, async, and so on. You need to have variations. That was my first implementation. And then there was this guy from Amsterdam that I showed my previous at the beginning. He came with that idea. Well, let's do it with the event magnet, and he implemented. And I said, well, it's a good idea, and he did it, which I'm very happy. But it's a good point. Maybe we should see if we can also have implicit conversion directly, because it means that I will have here somewhere something that can convert my protocol to a future event. My event here to a future event, yeah? Yeah, it's a good point. I'll try it. Thanks.
Then it will apply globally in your entire application, right?
No, those implicit conversions, they live here, inside my DSL. So your question was if it will apply globally, and it's inside the DSL. So this will never be outside scope.
Okay.
So only when you are defining your DSL, you have this thing appearing, be available to your compiler. More questions? Was something that was not clear about CQRS and event storing, and because by giving this talk a couple of times, I realized that the most hard part to grab is CQRS. Actually, it's even not Akka or Scala, or at least people don't ask many questions about Scala Type System, and more about event processing and so on. Okay, I think we still have 5 minutes, 6 minutes. No? Yeah?
I'm not very experienced with, for example, Cassandra-like databases. But do you think your concept of this actor, which has his own threads and his own persistence, can be applied to a database that can be tweaked for less consistency or more availability or less?
Yeah. So the question is if we can build a database system on top of Akka and use, with some fine tuning, design if you want have more or less consistency.
Yeah, especially for the actor, when you say it has to be a node singleton.
Yeah.
Does it translate to any tweaking on scalability or fault tolerance or stuff like that?
Yeah. The reason why the actor has to be a cluster singleton is that it depends on its internal state to validate a command. And that internal state is also built from its events. So if you have two instances of this actor on different nodes, or even the same nodes on the same machine, you cannot guarantee that they have the same state. And you may validate a command that's invalid according to state living on another memory space. So you cannot tweak that. That's something that's inherent from the CQRS application, from an aggregate approach. But of course, you could imagine other ways, other usage of Akka, and how you could have state living inside an actor that at some point will be flushed to a database, for instance. I don't know if it's what you were meaning about having something that where you can decide the consistency level and flushing the data. It could be. I have no experience with that, and but I think we need to have some kind of versioning, like optimistic lock, and say, okay, this state here, I cannot flush because it's not in sync anymore. So that will probably be something that we need to have, a kind of optimistic locking. Yep.
Actually, that is a map reduce pattern you would use there. So you would map from all your aggregates to a reduced common aggregate.
Yeah, so comment is that we could use map reduce to map from different aggregates and converge all the events to one to the final aggregate. I'm not sure if we could do that because of the validation of the commands are dependent on the ordering of the events, and that could be very tricky to do that, and if not impossible. So I won't go to that on that direction, I think. But indeed, as you mentioned during the break, that we could optimize things and having an aggregate that can live in different nodes, different instances of the same aggregate, when it has a state that can accept message without generating inconsistency. And then you could have such a thing. Imagine that you have an aggregate at the start, and for some time or in its whole life, it's okay to receive, because you're not validating much. You're just accepting. It could be. We have 3 minutes. We can also catch up after the talk and have some more look inside the code. There are other things in that library. I will just leave then. The first URL is where you can find the code. The fun CQRS is how we call it, and it's on GitHub. And please have a look. If you like it, fork it, improve it. It's very early stage. It's not. It will never be a huge library. It's very contrived what you can do with CQRS. But there are some nice stuff that we are planning to do there, and there are some stuff to be finished yet, and also documentation. It's not. I said first I will finish my Devoxx talk and then I will write documentation. That's all. That's what everybody promised. Huh? They said I first give my Devoxx talk and then I write documentation. So now I promise it publicly, so I have to do it, and it's recorded. Okay. Thank you very much. Please. And don't hesitate to catch me on outside for more questions. Thank you.